For years, China has been building its naval might, determined to challenge U.S. dominance. At the center of this ambition stands its latest aircraft carrier, the Type 003 Fujian, a warship Beijing claims can rival America's USS Gerald R. Ford. But can it really? Is the Fujian a game-changing naval powerhouse or just an overhyped symbol of ambition that's still leagues behind the world's most advanced carrier? Today, we're cutting through the hype. We'll compare these two maritime giants in terms of firepower, technology, and global reach. To understand how these two carriers came to dominate naval discussions, we need to look back at the histories that shaped them. The USS Gerald R. Ford is the latest in a long line of U.S. aircraft carriers, with roots stretching back to the 1920s. The U.S. Navy's carrier program began with the commissioning of the USS Langley in 1922, marking the dawn of naval aviation. Over the next century, the U.S. perfected the art of carrier warfare through technological innovation and combat experience, culminating in the Ford-class supercarriers. The Ford, commissioned in 2017, represents the culmination of this legacy. In stark contrast, China's Fujian is a relatively recent addition to the naval stage. Until the early 2010s, China lacked any operational aircraft carriers. This changed in 2012 with the commissioning of the Liaoning, a refurbished Soviet vessel that served as a crucial learning platform. Just 7 years later, China launched its first domestically built carrier, the Shandong. But it was the unveiling of the Fujian in 2022 that truly signaled China's intent to rival the world's naval powers. China has made impressive strides with the Fujian, but let's put things into perspective. We are comparing nearly a century of U.S. carrier development with just over a decade of accelerated Chinese expansion. While the Fujian marks a bold leap forward, China's carrier program is still in its infancy relative to the U.S. Navy's long-established legacy. Can the Fujian truly emerge as a major threat to U.S. naval dominance, or is it still a promising contender learning the ropes? So, let's start digging deeper. China's Fujian was introduced with great excitement, aiming to transform the country's naval power. At approximately 1,036 feet in length and with an estimated displacement of 80,000 to 85,000 tons, it is the largest warship ever built by China. However, its design reveals some shortcomings. While its size is impressive by Chinese standards, it still falls short compared to the Ford, which measures 1,092 feet and displaces around 100,000 tons. While a 15% difference in displacement might seem negligible, in naval engineering, every ton counts. Greater displacement means more room for fuel, ammunition, and aircraft, critical elements for sustained combat operations. Moreover, the island structure is bulkier and positioned closer to the ship's center, limiting available flight deck space. The Ford's smaller, aft-positioned island maximizes aircraft operations by providing more open deck space. Another critical design flaw of the Chinese carrier is its limited aircraft elevator configuration. With only 2 elevators, the ship faces logistical challenges in quickly moving aircraft between its flight and hangar decks. This bottleneck could critically reduce its sortie rates during combat. In contrast, the Ford features 3 advanced electromagnetic elevators for aircraft and 11 weapons elevators, all designed for maximum operational efficiency. These elevators enable rapid rearming and deployment of aircraft, providing a decisive advantage in high-intensity operations. Just a quick moment before we move on. If you're new here and you like this content, consider subscribing to sustain our work and help us create more videos like this. Moving on, another significant disadvantage of the Fujian is its propulsion system, which limits its ability to stay at sea for extended periods. The ship is powered by a combination of steam turbines and diesel generators, a conventional setup that limits its operational range. This system requires frequent refueling, forcing the carrier to stay relatively close to friendly ports, a critical vulnerability during extended missions or combat deployments. By contrast, the Ford is equipped with twin A-1B nuclear reactors, providing virtually unlimited range and endurance. These reactors can power the carrier for decades without refueling, enabling continuous global deployment far from home bases. The difference couldn't be more striking. While China's latest carrier might be able to project power regionally, it lacks the long-range endurance of its American counterpart. In a sustained conflict or global crisis, the Fujian's need for frequent resupply would be a severe operational limitation, placing it at a clear disadvantage against a nuclear-powered supercarrier like the Ford. When it comes to launching and recovering aircraft efficiently, the true measure of an aircraft carrier's power, the Fujian faces significant challenges. The ship is equipped with 3 electromagnetic aircraft launch systems, or EMALS, a cutting-edge technology that uses electromagnetic force to catapult aircraft off the deck. Unlike the outdated ski jump configuration used on its predecessors, EMALS generates more consistent and powerful launches, allowing heavier, more advanced aircraft to take off with less stress on their airframes. However, China's implementation of EMALS remains unproven in real-world operations, raising concerns about reliability during high-tempo missions. The Ford, by comparison, features 4 EMALS catapults, providing a crucial operational advantage. With an additional launch system, the ship can launch aircraft more frequently, enabling higher sortie rates during combat operations. Its system has been battle-tested through extensive real-world operations, proving its reliability and effectiveness in high-intensity combat scenarios. Equally critical is the recovery system. The Fujian relies on a traditional hydraulic arresting gear, which is prone to wear, hydraulic fluid leaks, and higher maintenance demands. In contrast, the Ford employs advanced arresting gear, or AAG, a more efficient system designed to handle a broader range of aircraft while enhancing safety for pilots. Another crucial feature that defines an aircraft carrier's combat strength is its air wing, an area where China's Fujian shows clear limitations. The ship is expected to carry 40 to 60 aircraft, including a mix of J-15 fighter jets and potentially next-generation J-35 stealth fighters. While promising on paper, these aircraft remain limited by the carrier's smaller hangar space and unproven sortie generation capability. In contrast, the Ford can carry up to 90 aircraft, including FA-18 Super Hornets, EA-18G Growlers for electronic warfare, and E-2D Hawkeyes for early warning operations. Additionally, the U.S. Navy has mastered high-tempo flight operations after decades of experience. China, with far less operational history, faces a steep learning curve in coordinating complex carrier-based missions, a critical factor in any future combat scenario. When it comes to weapons and defensive systems, the Fujian still falls short. The ship is expected to be armed with HHQ-10 surface-to-air missiles, designed for close-range defense against incoming threats like cruise missiles and aircraft. Each launcher is expected to carry 24 missiles with an engagement range of approximately 5 to 7 miles. These missiles are roughly equivalent to the U.S. Navy's rolling airframe missile system, but lack proven combat experience. For close-in defense, the carrier is believed to use several Type 1130 CIWS, close-in weapon systems. This rotary cannon system can fire up to 11,000 rounds per minute using 30mm shells, offering a last-ditch defense against incoming missiles and fast attack boats. Its multi-barrel Gatling design is comparable to the U.S. Phalanx CYWS, though with less advanced radar-guided targeting capabilities. However, China's defensive systems face limitations. Current open-source intelligence suggests the Fujian may lack a layered missile defense system, meaning it would depend entirely on short-range systems like the HHQ-10 and CIWS. This leaves the carrier vulnerable to advanced long-range threats, such as hypersonic missiles or stealth aircraft. The Ford, in contrast, features an integrated multi-layered defensive suite. Its evolved Sea Sparrow missiles have a range of over 30 miles, designed to counter advanced aerial threats, including enemy aircraft, cruise missiles, and drones. Each launcher can carry up to 32 missiles, providing long-range coverage. Complementing this system are rolling airframe missiles, similar to the Fujian's HHQ-10 but with extended engagement capabilities, especially when used in concert with the ship's long-range radars. Additionally, the Ford's Phalanx CIWS serves as its final line of defense, capable of neutralizing threats even after they've breached its missile shield. The ship's advanced ANSLQ-32 V6 electronic warfare suite provides electronic jamming, radar spoofing, and threat interception, enhancing its survivability in high-intensity combat scenarios. A carrier's survival depends not only on its weapons, but also on its ability to detect, track, and engage incoming threats. In this regard, the Fujian lags behind due to less advanced radar and sensor technology. The ship is expected to feature an active electronically scanned array, or ESA radar, a modern sensor system designed to detect and track multiple targets simultaneously. While ESA technology represents a considerable improvement over older mechanical radars, China's system is believed to be less advanced than its US counterpart due to lower signal processing power and more limited software integration. Additionally, its ESA radar likely lacks real-time data fusion capabilities comparable to Western systems. This means that while the radar can track multiple targets, integrating that data into a combat management system for quick, automated decision-making might be slower and less precise. The Ford employs a revolutionary dual-band radar system, combining X-band and S-band radars. This unique setup allows the carrier to perform long-range air surveillance, missile tracking, and surface target detection simultaneously. It can detect incoming threats at hundreds of miles away, processing and prioritizing them in real time. The X-band radar specializes in high-resolution targeting and precision tracking, essential for guiding missiles and close-in defense systems. Meanwhile, the S-band radar provides broader, long-range air surveillance, detecting distant targets and tracking multiple threats simultaneously. This dual-band capability ensures seamless coordination between offensive and defensive systems, enabling the Ford to handle highly complex threat environments with minimal crew intervention. In contrast, the Fujian's reliance on a single-band ESA radar restricts its multi-role effectiveness, leaving it potentially vulnerable to stealth aircraft or long-range missile strikes. While advanced weapons, sensors, and combat capabilities define an aircraft carrier's offensive potential, its effectiveness also depends on its ability to sustain operations. The Fujian relies heavily on China's regional support network, primarily concentrated around the South China Sea, and limited overseas naval bases, such as the one in Djibouti. Outside these areas, China's logistical reach becomes challenging, especially when operating far from its home ports. The lack of a global replenishment network severely restricts the Fujian's ability to deploy in distant theaters for extended missions. Moreover, as mentioned earlier, the carrier's conventional propulsion system, requiring frequent refueling, compounds this limitation. Unlike nuclear-powered carriers, it must regularly return to friendly ports or be supported by replenishment ships, a capability China is still developing. In stark contrast, the Ford benefits from the U.S. Navy's global logistics network, considered the most advanced and extensive in the world. Supported by a fleet of replenishment ships, the Ford can receive fuel, ammunition, and supplies while at sea through underway replenishment operations. This capability ensures continuous global deployment with minimal downtime. Additionally, the Ford leverages a vast network of allied naval bases spanning multiple continents, including key locations in Europe, the Middle East, the Pacific, and beyond. This worldwide network enables seamless resupply, maintenance, and personnel rotation, ensuring sustained combat readiness anywhere on the globe. China's Type 003 Fujian is built for regional dominance, focusing on the Indo-Pacific theater, especially around Taiwan, the South China Sea, and the East China Sea. Its mission aligns with Beijing's strategic ambitions, asserting control over contested waters, countering U.S. naval presence, and deterring powerful regional rivals like Japan, India, and Australia. But while the Fujian casts a long shadow in its home waters, its reach fades when the global stage comes into view. Meanwhile, the USS Gerald R. Ford stands unrivaled, projecting power and shaping international policy with its sheer presence. Until China can bridge the gaps in its logistical infrastructure, operational endurance, and global support network, its dream of a blue-water navy capable of dominating the world's oceans will remain just that, a distant aspiration, not today's reality.